All right, we are looking at writing the equation of conic sections whose center is not at the origin. Now the one thing here, just as we looked at graphing on Monday, circles are going to be the easiest. For everything else, I do recommend graphing it. Even a quick sketch can help us identify the center and other information that we need. I would also recommend that you refer back to the formulas provided on yesterday's notes, on Monday's notes, just to have the general shape in the equations. So how this will work is I'll go through the first example on the slide, and the second one I'm going to hit pause and then finish that one up and then hit play so you can check your answer as you go. All right, so number one, here we have the center at 3, 3, or 3, 1, 3, negative 1, and let me get the pen, and we have a radius at the square root of 10. So we're using that basic form for a circle, x minus h squared plus y minus k squared equals 10. Keep in mind 3 is our h, negative 1 is our k. So the equation of the circle is going to be x minus 3 squared. Keep in mind it's x minus h squared. Then plus y plus 1 squared. And it's going to equal our radius squared. And since the radius is the square root of 10, we'll square that, so it will equal 10. So that's the equation of the circle. All right, so hit pause, come back when you're ready to check over what you got for number 2. Welcome back. The equation for number 2 will be x plus 4 squared plus y minus 2 squared equals 9. All right, let's move on to number 3. So we'll work through this one together. And number 3 is, just ignore that Utra. Number 3 is the same idea. So we have our center, x minus 5 squared plus y minus 1 squared, and it's going to equal our radius squared. So we have 4 squared, which is 16, times the square root of 2 squared, which is 2. 16 times 2 is 32. So that's the equation of the circle described by number 3. Hit pause, do number 4, and come back. All right, number 4, the equation of that circle is x plus 5 squared plus y plus 2 squared equals square 7 times the square root of 3, so 49 times 3, so will equal 147. So that's circles. Those are going to be the easiest. Next, we're going to move on to parabolas. Now, parabolas we also looked at when the center wasn't at 0, 0. So this one you may be more familiar with because that's what we had the quiz on last Friday. So first thing here, I do recommend drawing a sketch just so you can see which variable will be squared, because with a parabola it's either going to be x minus h squared or y minus k squared. So just a brief sketch will do. So we have negative 1, 2 as our vertex, and then the focus is 4, 2. Now keep in mind the arms of the vertex need to hug the focus, so this parabola will be opening to the right. And since it's opening to the right, that means our y value will be squared. So we have hk. So that form will have y minus k, so y minus 2 squared equals, it's going to be 4p here, times x plus 1. Now keep in mind that p value is also going to be negative since it opens right. If this were to open up or open right, that p value would be positive. So that p-value, keep in mind, is the distance from the vertex to the focus. So our p-value is 1, 2, 3, 4, 5. So that means our 4 p-value will be 20. So our equation, we have y minus 2 squared equals 20 times x plus 1. All right, I want you to hit pause and complete number 6, then come back with us. All right, welcome back. So once again, a brief sketch for number 6. We have a vertex at 2, 5, and then our focus is at 2, 3. So the parabola is opening down, so that means our x value is squared. So we'll have x minus 2 squared equals sum 4p value times y minus 5. Now keep in mind, since it is opening down, our p-value here will be negative. So the distance once again from the vertex to the focus is 1, 2, but since it's down 2, our p-value is negative 2. So 4p, 4 times negative 2 will be negative 8, and that will go in front. Alright, next one we're going to take a look at when we have the vertex and the directrix. So once again, 5 through 8 are ones you're very similar with, or what we did last week. So once again, a brief sketch can't hurt. So we have 2, -4 is our vertex. Our directrix is x equals 1. X is a vertical line. And keep in mind the vertex does not touch the directrix, so it's going to be opening to the opposite side. So it's opening to the right, so our y value is positive, so we can start y minus k, so y plus 4 squared equals some value times x minus 2. Now here, since we're opening to the right, y is squared and p is positive. But we can also find p as the distance between the vertex and the directrix. And so since it's 1 unit, our p-value is 1, so 4p is going to equal 4 times 1, which is 4. All right, hit pause, complete number 8, and then check back in with us. All right, for number 8, once again, graphing helps. 1, 2, 3, 4, 5, 1, 2, 3. Here's our vertex. Our directrix is y equals -3.2. So go one beneath the vertex, and it's going to go halfway in between. And keep in mind, these don't have to be perfect, they're just good sketches. And once again, our vertex won't ever touch it. So that x value, is squared. So that first part will be x minus -5, so x plus 5 squared equals some value times y minus -3, so y plus 3. And so the distance, once again, from the directrix to the vertex will tell us our p-value. So that's another way you can take a look at it. So our p-value is positive 1/2. So 4p, 4 times 1/2 will be 2. So that's our equation. All right, next we're going to take a look at ellipses. Ellipses, once again, the drawing of the sketching is going to be really helpful for these. So once again, just do a brief sketch. So we have 5, 1, 1, 2, 3, 1, 3, 4, 5, 1. That will be a center. Our vertices are at 5, 6, 2, 3, 4, 5, 6, and then 5, -4, 1, 2, 3, 4. And then our co-vertices are at 3, 1, and then 7, 1. Oops, so we have the ellipse, and hopefully yours looks better than mine does. All right, few things here. We can tell it's a vertical ellipse, so that means that larger value is going to be under the y value. And we can go ahead and plot or write the equation out with the center. So it'll be x minus 5 squared and over something plus y minus 1 squared over something, and we know it's going to equal 1. Now we need to find the values underneath. Now the value underneath y will be the distance from your center to your vertices, either one, and that value squared. So the distance from the center at 5, 1 to the vertices 5, 6 is 5. So then we have to do 5 squared, so that will be 25. The value that's going to go underneath x is going to be the distance from the center to the co-vertices squared. So the distance from the center to the co-vertices is 1, 2. So 2 squared will give us 4. So that's the equation of that ellipse. All right, I want y'all to do number 10 and then check back in with us. All right, 10, once again, a picture can be helpful. So we have -1 as a vertice. Then we have -7. -1 as a vertice. Then -3, 2 as a vertice, co-vertice. And then -3, -4 as a co-vertice. Now this one, we don't have the center, but we can easily find it by looking at what the vertices, what value they have in common, and that will be the y value or the x or y value of our center, and what the co-vertices have in common. Now since the vertices, they both have a y value of -1, our center will have a y value of -1. Since the co-vertices have an x value of -3, that's the same, so will our center. So we can write this as x plus 3 squared over some value plus y plus 1 squared over some value, and it's going to always equal 1. So we have this information set. And if we want to go ahead and plot that center, we can. So the value that's going to go underneath x is, keep in mind, the distance from, for this one, the covertice, or the center to the vertice. So it's how we're moving horizontally. So from the center to the vertice, it's 1, 2, 3, 4. So 4 squared will be 16. The distance from the center to the vertical move, so in this case the center to the covertice, is 1, 2, 3. So that'll be 3 squared, which is 9. All right, the next one, very similar to number 10 above. So once again, you can start doing a sketch, but you can also use the same thing for the center. Since these have negative 5s in common for x, our center, the x value will be negative 5. For our covertices, the y values here are in common, and they're 3. So our center will have the y value 3. So we can go ahead and start writing this ellipse as x plus 5 squared over some number plus y minus 3 squared over some number is going to equal 1. So we already have that part set. And once again, a sketch can just help us identify this. So 1, 2, 3, 4, 5, 1, 2, 3. So our center. Our vertices are negative 5, 10, 3, 4, 5, 6, 7, 8, 9, 10. And then negative 5, negative 4. And the covertices we have 0, 3. And then we have 2, 3, and there's a typo on this. I realize something's wrong. All right, so on your sheet you'll notice you have negative 10, 3. That makes way more sense. 5, 6, 7, 8, 9, 10. And keep in mind, if something you're graphing it and you realize this doesn't make sense, take a look back at it because it probably doesn't make sense. That one, we had a typo on my sheet. On your sheet, it's fine. But you notice I sort of paused there because it wasn't working out. All right, so the distance from the center to the vertice, keep in mind since we're going up and down, that value squared will be underneath the y. The distance from the center to the covertice here, since we're going horizontally, will be the value underneath x. So y is dictating how often we go up and down. So from the center to the vertex, 7 units, so 7 squared, we have 49. The distance from the center to the covertice is 5. So 5 squared, we'll have 25. All right, for 12, this one's a little bit different. So a few different things you can do here. Once again, I think graphing, just through a brief sketch, helps a lot. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. And keep in mind, this isn't necessarily perfect, but it just gives me a general shape of that function. And then we have the vertices negative 2 plus or minus 4 times the square root of 4. Now a few things here, since you'll notice the vertices is on the horizontal, that means our larger value for our ellipse will be underneath the x function. And the smaller value will be underneath the y function. So there are a few things we can deduce based off just giving that vertex. So one thing here, we can figure out where the center will be since it will lie in the middle of the vertices. One approach you can go to it is to find the midpoint between negative 8, 4 and 4, 4. So where you add negative 8 plus 4, which gives you negative 4, then divide that by 2. So our center will have the x value negative 2. And then 4 plus 4 is 8. 8 divided by 4 is 4, which makes sense that it would also have the y value of 4. So that's our center. So we're going to fill this in, x plus 2 squared. That will be y minus 4 squared. Or you can just count. There are 12 units in between the vertices. So half of that is 6. So you go to the right 6 and then to the left 6 to find that center point. Now the next part, we're going to be using this value right here. 4 times the square root of 2 is the c value. Now everything with the foci, this is what it's related to. which makes sense since it's labeled that. So c squared, if we were to square this value, we get 16 times 2, so c squared equals 32. And if you remember the equation for the foci of an ellipse, it's c squared equals a squared minus b squared. Now here we know what c squared is, and I'm just going to write it down here. We know it's 32. We also are able to find a squared, and once again that's going to be the distance from the center to the vertice, or each vertex, which is 6. 6 squared is 36. So a is 6, so a squared equals 36. So we can substitute in 36 in for a squared, and then we have minus b squared. So here we're solving for b squared. So if we subtract 36 from both sides, we'll get negative 4 equals negative b squared. Divide or multiply both sides by negative 1, so we get b squared equals 4. So we'll go underneath that y value. All right, next we're going to take a look at hyperbolas, and once again sketching is going to be very beneficial for these particular questions. And what we'll do, we'll go over 13 and 14 together, and then I want you to hit pause and do 15, and then I want you to see if you can remember the information about 16. So once again, we'll be graphing, and on your notes you have something slightly different than what I have here. I do not know how I messed this up so much. Alright, so keep in mind we're doing the same thing that's on your sheet. Don't worry about fixing anything. Alright, so we have the center negative 2, 4, and then we have the vertices negative 2, 6, and then we have negative 2, 2. Our vertices will open up, will open down. So since the parabola, one opens up, one opens down, that y value is going to be first. So our center of negative 2, 4. So it's looking at y first, we need that k value. So y minus 4 squared minus x plus 2 squared. There are some values and they equal 1. Now we also have some covertices, but we can go ahead and identify, in this case, what the b squared value will be based off the distance from the center to the vertex. So from the center to each vertex is 2 units. So here our b value is 2, so b squared is 4. And then we'll do the same thing with our covertices. Those are the value 1, 4, and then negative 5, 4. So the distance from the covertices to our, or excuse me, the center to the covertices is 3. So we have 1, 2, 3. 3 squared is 9. So that's the equation of that hyperbola. So we have 2, 3. Now on 14 we have the vertices. I don't know how I messed this up so much, but we have the vertices negative 1, 1 and 5, 1. So once again, plot those. 1, 2, 3, 4, 5. And then we have the foci at negative 3, 1 and then 7, 1. And keep in mind the arms of the vertex will hug the foci. So here the hyperbola is opening to the left and to the right. So that means that x value will come first. So that y value is going to be subtracted here. All right, it's going to equal 1. So hyperbolas and ellipses, the standard form, will always equal 1. All right, so here we need to find the center point. Now keep in mind the center point is going to be in between the vertices. So the vertices are 6 units away from one another. 1, 2, 3, 4. Is that right? Yep, it's a little over here. 1, 2, 3, 4, 5, 6. So the center is going to be halfway in between them. So it's going to be 3 units in between the vertices. So 1, 2, 3. So our center point is 2, 1. So we can write out 2 and 1 here. And then the value that's going to go underneath x is going to be the horizontal distance from the center to the vertex here. So that will be 3. So keep in mind it's always the squared value. So we'll have 9. And then underneath y, we're going to use what we know about the foci. So we know the equation for the foci of hyperbolas are c squared equals a squared plus b squared. So our c squared value, we will be able to find, let's go ahead and substitute the a squared. So that b squared value is what we don't know quite yet. Now c is the distance from the center to the foci. So our c value is 1, 2, 3, 4, 5. So our c value is 5, so c squared will be 25. So subtract 9 from both sides, so we get 16 equals b squared. So that second denominator will be 16. All right, I want you to hit pause and work up 15 and then check it with us on the next part. All right, 15. So these are right. I don't know why those two are just completely off. All right, so our vertices here, once again, just draw a brief sketch. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And if you feel comfortable identifying these without a sketch, you're definitely able to do that without a sketch. All right, so our center is going to be in between them. So our vertices are 4 units away, so the center will be 2 units away from both of those. So the center of our hyperbola is negative 3, 5. Keep in mind, since these arms are opening up, our y value is going to go first. So we'll have y minus 5 squared over something minus x plus 3 squared over something equals 1. And you can fill in the equation step by step as you see fit. You don't have to wait till you have it all done. Underneath y, it's going to be the distance, the vertical distance, so from C to 1 point. So that's 2 units. So 2 squared will give us 4. Now here we're also going to be using the foci. Here for the foci, our c value is the square root of 13. So c squared equals 13. So we have the equation 13 equals a squared plus 4. And it doesn't matter where you substitute in, because once you subtract 4, you still can get 9 is a squared. And that will go underneath x. All right, the last one is 16. This one we can take a look at together. And 1, 2, 3, 4. 1, 2, 3, 4. Do the vertices, and then we have 8, 4. And once again, that center is going to go smack dab in the middle. And since the vertices are 4 units away from each other, the center will be 2 units away from either of them. So our center we have at 6, negative 4. Now here, the arms are opening to the right, because we can't draw the arms from the vertices any other way where they won't intersect. So here that x value is first, so we'll have x minus 6 squared, then minus y plus 4 squared equals 1. And that one sort of disappeared. So our horizontal distance, keep in mind, will always go under x. So the distance from center to vertex here is 2. So 2 squared is 4. And then we're going to be using this slope. Now this is going to come back into a few different things of when we took a look at when the center of a hyperbola was at 0, 0. The equation for the asymptote was always y equals plus or minus b over a times x. So this part is that plus or minus b over a. So our b value here is 5 and our a value is 2. Now that makes sense since a squared is 4 and we found that to be true based off the center's distance from the vertex. To find that b squared value, 5 squared is 25, which will go underneath that y value. All right, your homework for tonight is page 196, problems 13 through 22. And also keep in mind the sheet from Monday, page 196, 1 through 12 is also due tomorrow. You should have time to finish some of the homework in class today, and I will see y'all tomorrow.